Okay? So let's refresh some weekend foggy brains about how we find the inverse. Okay, so we're putting away the papers that I just gave you. We got out our pencil and a piece of scrap paper over at the side of our notes, and we are going to find the inverse of this. Okay? So who remembers how we even start this thing? Pat.
First off, we turn the f(x) into a y.
So we think of this as a y because that's what it is. I was just observing a calculus class, and guess what? In one problem he had f of x, and in the next problem he had y, and the problems were exactly the same because f of x is the same as y. Now what do we do?
Now you replace the x's with the y.
We flip-flop the variables. So x equals 3y minus 1 over 4y plus 2. Remember that from the other day, folks?
Yes, ma'am.
Okay. Now, your ultimate goal is to end up with y equals. Instead of x equals, you want to end up with y equals. So how do we make that happen? This takes several steps. How do we do that?
Cancel out the denominators.
We bring the denominator over here, right? Bring the denominator over here. Multiply it over to here. Which means what's going to happen right here? We're going to have a distributive. So 4xy plus 2x equals 3y minus 1.
If the y is the same side.
Now we're solving for y. We want to end up with y equals. But there's two of them in the problem, right? So do you remember what we do?
Get the y on the same side.
Move the y's to the same side. You could only have one y in your final answer. So I'm going to do some rearranging, which ultimately means this one's coming over here, and this one's coming over here. So 4xy minus 3y equals negative 2x minus 1. This is over here, negative 2x. This is over here, negative 3y. Now that I have both y's on the same side, what can I do?
Factor out the y.
Factor out the y. So when I factor out the y, I'll have 4x minus 3 equal to negative 2x minus 1. And now remember, this is your goal. Your goal is to say y equals.
Negative 2x minus 1.
So negative 2x minus 1 over 4x minus 3. And then, if we want total final 100%, we have to answer back in function notation. Miss Ford, that's so technical and picky. Yes, it is, but it's the way we're going to do it because that's the way the problem started, right? It doesn't say find y, it says find f inverse. So we're going to say, okay, this is f inverse. Okay, do you remember those steps from last time?
Yep.
All right, let's go through one more. And this one I'm going to have you try a little bit on your own before I jump in. So let's say the function is 6x plus 8 over 3 minus x. All right, so your job is the same. You are finding the inverse. So you're going to go through those steps exactly the same way. Sam, you got this down already? Just normal, do you have these a lot? Or? Okay. Do you have to take photos before you go in? Wash your fingers. Yeah. I get past ants all the time, and I teach her claustrophobic. So the first couple, I took a anti-anxiety thing because I couldn't handle it. But then, the next time I went in, I went back to school. I just I couldn't handle it. And now I do them all that way because I'm used to it. And that first one I thought was terrible. Good luck to you. Focus on some pre-cal while you're in there. All right. I hope you started like this. And then I hope you did this. Okay? Every inverse problem is going to start that way. Every single one. Even the super simple ones are going to start that way. Okay? Now this is where, though, this is a little more complicated. So, Maddie, what do we do now? We do. So we have this. Okay? Q, what happens next? First I have to distribute. My goal is to get y by itself, but I'm not ready to do that yet. I distribute. You're right. I distribute. Okay? Mr. Stewart, what happens now? All the y's, anything with a y goes on one side, everything else goes on the other side. So I'm going to have to bring the y over here and bring the 3x over there. So I have a negative xy and a negative 6y on this side, and a negative 3x and an 8 over here. So does everybody see this term had to come over here, and this term had to come over here? Does everybody see that? Yeah. Now, the order that you write these is not important. So if you have negative 6y first, that's fine. The order is not important. You gotta have these two on this side and these two on this side in any order. Tex?
I moved the y's to the right side.
That would be fine. So then you have 3x minus 8 equals xy plus 6y?
Right.
Yeah, that's fine. I've been, in all my problems, I've been moving the y's over here, but there's no rule that says you have to, so this is absolutely fine. And in fact, this has less negatives, so in some ways it's easier, right? Okay, so regardless of whether you moved everything right or moved it all left, what's the next step?
Back out the y.
You gotta take out the y. So no matter which side you got them on, you're gonna take them out. So I'm coming back to mine, and I'm gonna pull out the y. Now, we talked about this last time. Even if there's more than just the y that you can take out, don't. Take out the y, period. Don't take out a 2y, don't take out a negative y, take out y. So if I take out y, I'll be left with negative x minus 6. And then I'll divide by that parentheses, and that will make my y all by itself. Now, I'm grading my paper, and this is what I have. I'm grading Tex's paper, and this is what he has. And guess what? They're both right. Because it just depends on which way you move things, what you made negative. These are both absolutely correct. So no matter which way you have it, they're both right. Okay?
Why would you do all that work when you can just
Why is there?
like?
Because in 2 weeks you won't remember, Brendan. I promise you won't.
But there's
Sure, there's a pattern. You do the same operations every single time, but you're not going to remember that, right?
Yeah.
so on the quiz you want me to show that?
I do.
Okay.
Izzy?
Why is it 3x minus 8 and x plus 6? Because I know like
Okay, wait.
3 over
Is this
x.
what you got?
Yeah.
Okay, stop there. That's fine.
Oh, you're talking about what he. Okay.
Yes.
Sorry.
Yeah. So what my point is, our answers may not look exactly alike, but they can still be both right, depending on what strategies you used when you did the problem, how you move things around.
So how'd you get to negative x minus 6 over without changing the signs?
I divided it. It's a division problem.
Oh.
I didn't add or subtract. I divided because that's a times. Y times that, so I divided both sides by that.
Make cancel.
Okay? So tomorrow, first thing, we're going to take that quiz. Okay, we're not reviewing anymore. That was it. We just did 2 problems. That's your practice.
Can I have it now?
So tomorrow, you're going to get one and you're going to do this. Okay?
I can't take it now.
No. Because we're not ready. And I said, originally I said it would be the next day. Okay, so now get your notes out. We got to finish up a couple of things here and then get started on some really exciting things.
Oh, yeah.
Yes, sir.
Wait,
Yep, back in our notes. So we are on page 12. Page 12 of our notes. And the very last thing that we did last time was problem 3A. So if you remember, I had you label these points. So I'm going to ask you to do the same. We're on 3B. I'm going to ask you to label the points. This time it's easy. There's only 3 of them. Label those points. We are on page 12, problem 3B, because the last time we were together, we did 3A. Now we are sketching the inverse. Who remembers why I had you write down label these points, write down the coordinates? Who remembers why we did that? Because to plot the inverse, we flip these, right? Actually, we flip these. So instead of plotting the point -2, 0, which is the original, I'm going to plot the point 0, -2. And then 0, 2 becomes 2, 0. And 2, 0 becomes 0, 2. And then I connect those, and guess what? The shape is the same. It's just on the opposite axis. Because what was x's became y's. Remember how we switched those? When we're writing the equations, we switch x and y. That's exactly what happened graphically. It did sit on the x-axis, now it sits on the y-axis. So when we graph inverses, it's really simple. All we do is reverse all of the ordered pairs, right? We reverse the ordered pairs. Okay. Now, part 4. The first part of this is easy. The second part is a little bit trickier. All right. So your job is to find x and y.
Oh, you're gonna plug the one. Yep.
So for the first problem, this is A. You are told that t is 1. This is easy.
And all the equations have 2 in
If x is 2t plus 1,
it. 3.
but t is 1, then x must be 3. Right?
Y is
And if
negative
y is negative 3t, but t is 1, then y must be negative 3. This is simple. You're just plugging in whatever t value they give you. So over here, they're scarier equations, but it doesn't matter. You do the same thing. If we put in 7, what happens?
3. You're gonna get 4.
We get the square root of 4, which is 2. And then if we put in 7, we get
49.
49. Done. That is easy. Nothing complicated with that. Now this next set, just reading the directions gives us a rash. These are complicated directions. What are they talking about when they say, find the direct algebraic relationship between x and y? That means, I'm going to translate that for you. That means combine into one equation with no t. So right now, you have 2 equations, and they have t's. You're going to put those together and write one equation, and it ain't going to have any t's in it. It's going to be just x's and y's. A direct algebraic relationship between x and y. It's going to be one equation with x's and y's. Now, does anyone have a thought on how we might accomplish that? Yes.
Replace the t with like the x and then replace the t with the y.
Okay, I think you're on track. Let's look at this equation right here, the second one. What does t equal? I'm looking at this equation right here. What does t equal?
Y over negative 2.
Y over negative 2?
Plug in y over negative 2 for the 3t, and then you get the
All right, if you're saying what, stop it. That's embarrassing. We're looking at this equation. It isn't cool to speak before thinking. Spend a second and think about it. I told you I drew an arrow. I said, look at this equation. What happens if I divide both sides by negative 2? I have t equals y over negative 2. It's called solving for a variable, and you can do that. Give yourself some credit. Now, if this is, could I do the same thing with the top one? Yeah, wouldn't matter. But I did it with this one. Now, this is what t equals. T equals this. Guess what I'm going to do with that?
Plug it back in.
I'm going to take it up to the top equation, and I'm going to substitute it in. Let's look at what we'll have if I do that. X equals 3 times y over negative 2 plus 1. Now I want you to look at that equation right there. How many equations are there right here? 1. Does it have any t's in it? No? So I'm almost done. I just have to clean this up a little bit, and then I've done the job. So what happens when I multiply these two together? What does that equal?
3y minus 6.
3y over negative 2. Remember, we're multiplying fractions, so it's going to be 3y over negative 2 plus 1. Is that okay? Normally, we don't want fractions in our final answer, so what could I do to eliminate the fraction?
Divide.
I wouldn't divide. I would multiply everything by negative 2. So then that equation would look like what? Negative 2x equals 3y minus 2. Notice I times everything by negative 2. So I canceled that, but I put a negative 2 here and a negative 2 here. Now, I'm not gonna mark that wrong, but if I were doing the problem, I would probably take it one step further. And write that. What did I do here? I put the 3y over with the x because it's the equation of a line and that's the standard form. You might even want to get rid of the negatives if you wanted. You could divide everything by negative. I'm not going to count that wrong. This would be fine. That would be fine. This would be awesome. I would do this if I had to do more with it, like graph it or something. But any of these is fine. You got one equation with just x's and y's. Not so hard. What did it hinge on? You had to get t by itself, right? Doesn't matter which equation you use. In one of the equations, you get t by itself, whichever one seems easiest, and then you plug it in. So let's look at the next one. The next one says x equals t plus 4 and y equals 7t minus 3. So in one equation, I have to get t by itself. So what do you think? I think it'd be easier on the top one, wouldn't it? Won't make any difference. Your answer will be the same, but it would be easier on the top. So what is t going to equal in this equation? X minus 4. Subtract 4. Then take this, which is the t value, and plug it in right there. So y equals 7 times x minus 4 minus 3. Let's clean it up a little bit. So y equals 7x minus 28 minus 3, or 7x minus 31. And that's beautiful because that's the equation of a line slope-intercept form. It's beautiful. So what did we do? We got to pick the equation, got t by itself, and plugged it in. One more. I'm going to do this problem twice because I want to prove to you that it doesn't matter which letter or which equation you use. So if we decided to use the top one, we wanted to use the top one to get t by itself. Let's see, what would we have to do? Subtract 4 and then divide by 2. Right? And then we're going to take this mess and we're going to plug it in right here. So y equals 3 x minus 4 over 2 minus 1. Plugging in that top equation, plugging it in right here. Okay, so now what do I have to do? Distribute. So y equals 3x minus 12 over 2. So 3 times the top, 1 times the bottom, minus 1. We can multiply by 2 next if you want to. Now when you times by 2, this is going to be 2y. This is just going to be 3x minus 12, because when you times it by 12, that cancels, or by 2 I mean. When you times it by 2, that cancels. And then minus 2. That's where people are going to make the mistake. When you times by 2, it's 2, 2, 2. So 2y equals 3x minus 14. And then I would like to do this. You don't have to. So I'm gonna have this. But this is fine. But I'm gonna show you they're gonna come out to be the same. So I'm gonna want it to look like this. Okay, now you've done the problem, it's finished. But let's go back and do it again. Only let's use the bottom equation. So we're gonna do exactly the same thing, but we're gonna use the bottom equation. What's gonna happen? I'm gonna end up with the same answer, hopefully, right? You never have to do the problem twice. I'm doing it twice for practice, okay? So, if I use the bottom equation, let's get y by itself. I'll have what? Y plus 1 equals 3t. Y plus 1 over 3?
Yep.
Now I'm going to take this right here and put it right here. So x equals 2 y plus 1 over 3 plus 4. Now I'll distribute. So 2y plus 2 over 3, because this is 2 over 1. So 2 times the top, 1 times the bottom. Multiply by 3, so I have 3x. This cancels, but I take that times 3, so I get 12. Uh-oh, you see what's going to happen? So I have 3x equals 2y plus 14. And if I move over the 2y, is that the same equation that I got the first time? Yes.
Just the signs are
If
different.
I just divide everything by -1, they'll be the same equation. So, I did the problem twice. You do not ever have to do it twice. I did it twice so we would practice extra and so that you could see it doesn't make any difference which equation you start with. Okay? All right. Okay, good. All right, now we're ready for the next page. We're gonna do some heavy-duty sketching. Look.
Do you always leave it in like standard form? Is there any time that you would like?
It's best to leave it in either standard form or slope intercept form.
Okay.
So that would be best. If you got it to this point, I'm not gonna mark that wrong, but it really is best to use one of the forms.
If we could like divide out, like, take it out into threes, would we do that for?
Yeah, we don't want to introduce fractions unless because you can't divide all these by 2. But if you're gonna put it in slope intercept form and divide everything by 2, so y equals 3 halves x minus 7, that would be fine. Because that's slope intercept form, so that would be okay. All right, I hope, before I turn the page and go to this next section, I hope that you made a notation in the directions what it means back there in part 5 when it says find the direct algebraic relationship. What does that mean? Combine them into one equation that has no t's. And we accomplish that by solving one of the equations for t and then substituting it in. Okay? Now, this next section is all review except for a couple. So that's good. So let's look at this next section and let's talk about sketching. This first part is definitely review. That versus this versus this. We should know this. This was on your test. not that many, all parabolas, but you had a parabola on your test you had to do this with. Okay, first of all, I said it's a parabola, right? You knew that because it's squared. And you know that it normally is going to look like this, right?
Yep.
What happened to this one? Down 3. So you have your parabola down here at 0, -3. Everybody remember that? When you tack a number onto the end of the problem, you just take your function, there's my function, and I just stick a negative or a positive on the end of it, that moves it up and down, right?
Affecting the y, not the x.
He's out cold. Would somebody wake him up?
My God.
Are you sick? Do you need to go see the nurse? Okay, well try to stay awake, okay?
Sorry.
All right, next, what happens here?
You're affecting the x, so it goes left to right.
So that's different than this. Here I can see my function. Here the number is inside the problem with the function, right? So that's going to go left and right, and that particular one is going to go right. These rules are not going away. So if you were a little sketchy on them when you took your test, you better get unsketchy because we're adding more rules. We're adding more. More rules. There's a bunch of them. Right, flex groupies? There's a bunch of them. You guys have been coming in for flex? No. Okay. What happened here? I did 2 things.
Left 1, down.
So it's going left 1 and down 2. So left 1 and down 2. I have that parabola. Now the next set of problems are all different functions. And what we're talking about here is the impact of negatives. Now, you know how you can put numbers either outside the problem or inside the problem? You can put negatives outside the problem or inside the problem. And that makes a difference where the negative is. So, this is easy. We talked about this. What does putting a negative outside the problem do? That's right, Gabriella. It turns it upside down. So a negative out in front takes your normal picture, it's a V, and makes it upside down. A negative out in front turns your picture upside down. So where is this negative? Out in front. So it's going to turn my exponential upside down. So it's going to just take this and fold it over. Right? Turns it upside down. So it's going to look like this. And this was the 0.01 in the original. So now it's going to be the 0.0 -1. A negative out in front simply takes your picture and flips it over the x-axis, folds it over. This negative is not in front. A negative that's buried inside the problem is a reflection across, or a flip across the y-axis. So in other words, it's left to, or let's say it's a sideways flip. This is going to be a sideways flip. So a negative out front is an up and down flip. A negative inside is a sideways flip. So here's my original. There's my original. Now I'm going to take and fold it this way. So what I'm going to see is this. That's still the 0.01, but I'm flipping it this way. Let me get this out of there so it doesn't confuse you. There is the exponential with a negative exponent. A negative inside the problem folds you this way. Okay? All right, so now we got a lot going on here. Let's see, we've got negative x plus 1 squared. We have ln negative x. And we have negative ln x. Okay, so here we go. The negative is out in front, but there's a plus 1 inside. Okay, so what does this do? Not up one, this goes left one. It's inside the problem. Up 1, Toby, would be x squared plus 1, like that.
I thought we did another problem where it wasn't the parentheses. No.
If we did, I made a mistake and no one caught me.
Okay.
Because, no, this would be up and down, this would be sideways. So
Okay.
it's going left 1, but what does the negative do? Flips it upside down. So this parabola looks like this. It's shifted 1 unit to the left, and it's flipped upside down. Ashley, what flips it upside down?
The negative.
The negative where? Outside in front. Okay? Now this negative is not outside in front.
You're flipping it across the Y.
So a negative inside flips us this way, right? So my original picture, this is a logarithm. I'm going to go ahead and graph my original. Lightly with a dashed line. This is my original right here. But now what am I doing with that?
Flipping over the Y.
I'm flipping it sideways. So if I take this picture and fold it over, aren't I going to get this shape? And this would be the point -1, 0. Because I took the original and folded it. And now I'm going to take the original out of there. Don't want that to confuse anybody. That would be the picture. That is different than this one. Where's the negative in that one?
Flipping over
In
the
the
Y.
front. So again, I'm going to start with my original picture. Here it is. That's my original. That's ln x. And what does the negative in front do to it? Flips it this way, right? So I'm folding it this way. So see this guy right here? He's coming up. And this guy is coming down. So that is the picture of the upside down logarithm. The part that was down here below got folded up, so it's right here, and the part that was up here is folded down. So think of it as simply folding it over. Okay? Well, now the real fun's going to begin. I know you're thinking, oh my gosh, this has been so fun so far, but this is going to be really fun. So what I need you to do is take 2 pieces of this graph paper and pass it on. Take 2 pieces and pass it on. Stop complaining. Take 2 pieces and pass it on.
So I could just like, do I fall on the floor but have this squishy mat under there? And then I can do it. Is it do you have like a
So
soft
everybody's taken a couple pieces of this graph paper.
How many do you have?
And everybody needs a couple pieces and pass it on. Did I have enough? Where's my extra?
Jalen, do you have any extra?
Got a couple pieces and pass it on.
My bad.
Where's my extra over here?
I know. Video, great. Is it really squishy?
Yeah.
Maddie, a lot of me.
What kind of paper? How thick? Like, it's like this thick.
So like if you threw it under, not throw it under, if I place it there and I did my whole and tear something,
Yeah.
would I be okay?
No.
You know what's
Right. So, here is, you need one piece right now. Then give him one of yours. Okay, and then you can come get extra after class. All right, so now, here is what we are going to do. In your notes, problem 3 has this random shape. So after we take our one problem inverse quiz, the next quiz we take will be some random shape like this. And you will be asked to do some modifications to it. So let me get my thing graphed here. You have this already. I'm just reproducing it. So this random graph consists of this triangle right here, this triangle, and that triangle.
Showed us something like this.
That is our random graph. So that is what we are going to use for A through H. We're going to graph A through H on your graph paper using that as our baseline picture. So the first one, A, says sketch this. Now you know what that negative does. Look where it is. Where is it? It's out in front. So this is going to turn the picture upside down. It flips it upside down. So now we're going to graph the exact same picture. You're going to use your graph paper to help you. You have it easy because you have graph paper. And we're going to graph this exact thing but upside down. So, see this V right here? Instead of Ving down, he is going to V up. Everything is going to be exactly the same size. It's just Ving up. So instead of being 1, -2, it's going to be 1, +2. It's Ving up. Now, what about this little V right here? He's going to go down. I'm turning it upside down. So he's going to go down. So there's that V. Now what about this one? Down. So there's that one. He's going down now. And then this little one is going to go up. So there is the picture of this. How did I know that? Because I know a negative out in front makes it go upside down. A negative out in front makes it go upside down. Now, you don't have to write any of this down. You just get to draw the pictures because you have graph paper. So we're just drawing the picture. What does that negative do? Pay attention to where it is.
Flip it over the wall.
That makes it go sideways. So what that means is anything that's on the left in the original is going to be on the right. So I'm not flipping it up and down. I'm going to take this picture exactly, but this triangle is now going to be drawn on the right. So that triangle is going to be drawn on the right. There it is. This guy right here is now over here. Now, what about this triangle right here?
It's gonna go up.
Isn't he going over here?
Yeah.
We're switching sides. This negative switches sides. So instead of drawing this triangle on the right side, I'm drawing this one right here. I like to do it a piece at a time. Instead of drawing that triangle on the right side, I'm going to draw it on the left side. This triangle right here, I'm drawing on the left side. Now what about the big tall triangle? He's going on the left side too. And then finally, this little guy, he's over here below. And there we go. We have sketched this right here because that tells me to take the original and go switch sideways. Switch sides. Okay? So now we're going to do one more problem. You're all going to stay focused. We're going to do one more. Just one more problem.
Yay.
Here we go. Now, once again, we are starting with that baseline picture that's in your notes. So we're starting with the original right here. And we're adding 2 on the outside. So what does that do? What is that going to do to this picture if I add 2? It's going to take everything up 2. So it's going to go up 2. I like to make little notes there. Especially if you look down some of the later problems, we're doing 2 or 3 things at once. So I like to write down in words what I'm going to do. I'm going to take my picture up 2. So that means that every one of these points is going up 2. So if it is currently at 0, it's going to go up to 2. So -3, 2. There's my first point. It's over here at -3, 0, but it's got to go up 2. Now this one, wait, where is it right now?
2.
Where? It's at -2. This is at -2. So what's going to happen if it goes up 2? It's going to be right on the axis. And then that's going up 2. So here is my first triangle. That triangle right there has been lifted up 2. Now, this point is up 1. So it's going to be up 3. So there's my little triangle right there. There he is, but he's clear up there. This one is up 2 in the original, which means it's going to go all the way up to 4. So there's the big triangle. And then this one, now where is he right now? At -1. So if he goes up 2, it'll be at 1. And the other guy will be at 2. So there it is. There is your picture lift it up 2. All right, I will see you tomorrow for our one problem is, if you didn't get 2 sheets of paper, please come up and get another sheet. You're going to need it for your notes.